and I will try to speak in English, as today Kirk Pepperdine can be with us, and we are very proud. So just little detail, I will give just little detail about this session. Then Kirk will present you the product, and you can try a demo. The first time the demo is played here, and after that, like every time, we will have time to have questions, and then we can go to have a drink just under. So let me introduce Kirk Pepperdine. Kirk is normally in all around the world to teach about Java performance, and he's freelance for several years in Java platform performance, and he will present us today the product of its company, JClarity.
Thank you. I can talk with this one here. I don't need that one. Okay, how's that? Okay, well, thank you for spending your evening here with us. Maybe I should give you a little history. So, so we had this kind introduction saying that I do performance training and performance tuning, and I would say that this year has been a really interesting year because I started off the beginning of the year in a submarine, right? And we're probably going to finish the year dealing with cows, right? So, and there's been a whole bunch of things happening in between. Yeah, we're going to performance tune cows. No, we're not. But the submarine was interesting because we ended up, well, it's a video system, and you had all these strange icons like friendly torpedo. Does anyone know what a friendly torpedo is? Because I certainly would like to know what a friendly torpedo is. You know torpedo, yeah? Friendly torpedo? I just thought it would like wave at you before it said, "Hey, I'm here," and then blow up or something. I have no idea. But yeah, so it's interesting. But one of the things we find, what I've been finding across, after doing this for a number of years, is that, well, first off, I walk into places where we don't have a clue what people are doing, right? So the guys with the cows right now, I have no idea what they're doing, right? All I know is that they got to mess with the database and some EJB thing or whatever, right? JPA, whatever frameworks you guys cook up that can make things run slower, they've stuffed it in there. And with the submarine, of course, we had some, so with cows, we're dealing with real time. We did some airport stuff, so transactional rates are tied to aircraft landing and taking off. And of course, with submarines and video systems, now we're talking about having to hit a VSync, so we're down into like 16 milliseconds, a time frame. And the thing is, as we go across all of these different problems, you start picking up patterns, right? And you start seeing things in that are sort of common across all of the platforms that we're dealing with, and and then taking those patterns and actually doing like a higher order analysis on them, what we found is that we can take a lot of these patterns and we can categorize them. And we can say that when things are in this condition, I can tell you things about your application. And when things are in this other condition, I can tell you other things about your application, right? And so there's this whole heuristic model that we built up, after a number of years of just hitting, applications in banking and telco, in travel, in just you name the industry, we just go in, and there's just all of these problems that keep showing up, and they keep exhibiting the same types of patterns over and over and over again, right? So we figured, like, okay, people are using like App Dynamics. Anyone familiar with App Dynamics? New Relic, right? Dynatrace, and there's probably a whole host of others that I'm not mentioning. They're going to be annoyed at me for not mentioning them. Sorry. Oh, JX Insight, yeah. We definitely don't want William annoyed at us, do we? And anyways, we're looking at, okay, so how do these tools work? How are they working, right? Well, the guys are basically in, I was at App Dynamics this year, and I met with their CEO. They're in like downtown San Francisco, so they had like have a big room, about maybe 4 times the size of this office space here, big warehouse. People scratching their head, going like, okay, what can possibly go wrong with an application? Right? And they're saying, okay, well, let's, well, we don't know, so let's just collect some data, and maybe we can figure it out from the data, right? So what do they give you? They give you drill downs, yeah? So they said, something happened over here. You might want to take a look, and you go clicking through the drill downs, and eventually you say, the database sucks, or, this messaging system sucks, or something sucks, so we need to go fix it, right? And one of the things I'm saying is like, wow, it's not only that thing has gone wrong, it's like going like, drill downs suck. Why do we need drill downs? Drill downs suck. Why do we need them? Let's get rid of them, right? So, how do we, and all of this collection of data, it's like you look at how much data is being collected on a daily basis to sort out what's going wrong in your systems, and you just realize like, man, there's actually more compute power spent trying to figure out if your system is working than is actually spent on your system actually working, doing something. There's more bandwidth and more CPU and well, mostly bandwidth, just like, and disk and chucking around all of this stuff, right? Just in case. Just in case something goes wrong. And so, so you look at this problem, and then we see all these patterns and everything like that, and so like, why are we collecting all this data? And we can just collect a little bit of data over here, do a bit of pattern recognition on it, and then all of a sudden we've got a way of correlating certain patterns to certain problems in the application, and then we can sort of then tunnel in and do a deep dive and like really figure out what's going on, right? Am I stalling enough? Yeah. Okay. And from that, all of a sudden we get JClarity springing up, which is a how shall we say, a tooling company. So we have guys smarter than me, like Richard here, taking some of the stuff that I figured out and actually applying some really intelligent algorithms to it to try to sort out like what's really going on in your system. So I've sat in the App Dynamics offices with their team. We sat with Dynatrace with their team, and the New Relic guys won't talk to me, so that's okay. But these guys really are what I call on this 3rd gen of APM, application performance monitoring tooling, right? They don't know what's going to go wrong with your system, so we're just going to collect everything and hope we collect the right things, and then when we have the right things, we'll just present them to you in a way that you can just tunnel through it. And really what we want to do is we want to push the market into the 4th generation, what we call smart tooling. Now, I'd like to say we're the only company doing this, but that would be a lie. There are other companies that are attempting to do this. I'm not sure how successful any of us will be, but we're certainly going to have fun trying. Yeah, to do it. So one of the projects that we're actually working on, which is open source, is a memory pool viewer, right? Right now it just looks like a brain dead memory pool viewer because I need to check in the next version. The next version, there's some algorithms in there that are actually going to predict if your application is going to run out of memory a fair amount of time before it actually will. So that's what we want to try to do, right? In that case, so that's a bit experimental. So maybe it works, maybe it doesn't. But we can try. But that's just because we looked at so I collect garbage collection logs as a hobby, and so I've been looking at them, and as I looked at them, you can see certain patterns. If an application is going to run out of memory, certain things happen way before that happens, right? And so we can just look for these patterns, and we can use those patterns to say, okay, based on what we're seeing now, it looks very likely that you're going to run out of memory in a couple of hours from now. Maybe you want to take corrective action now before it actually goes critical. Yeah, as one thing is what we're trying to do. With this thing here, we're going to try to do deep diagnostics, right? Whatever's gone wrong with your system, we're going to try to figure out, okay, how's this, what's gone wrong, and then, give somebody a clear message as to what's gone wrong. Yeah? And So I guess another part of the story is that do you guys have to work with ops occasionally? Yeah. Do you just have trouble talking to them? They just don't understand what you're saying? Oh, you're okay with talking to them? You're ops, okay. Fantastic. Yeah. So do you like actually talking to development teams? Oh, really? Wow, you're an unusual beast. Normally it's like, they don't mix so well. So he's really nice with you. Fantastic. Wow. Okay. Okay, there blows my story. Sorry, we'll go on to the next one. So, what's that? Yes, because every time I say, yeah. Anyways, well, okay. So you're in the you got a nice guy. Like treat him really nicely because normally what I see is there's a little bit of a war between dev and ops, and they don't really speak the same language. So the other thing we wanted to do is be able to give ops a tool that they can just take the stuff out and sort of understand what's going on, and then pass it on to the dev, and the guys are really going to understand, what's going on in a way that you can. Basically, we can help with the communication gap between the two groups. You have to admit there is a little bit of communication gap there. More people. Okay, so so what we're going to try to do tonight is we tried to throw together a demo. Like I said, we're in startup mode. We're not really stealthy startup mode right now, but it means that we as any startup, we're running really from 1 minute to the next to get things to work. So we tried to put together a demo to maybe show you what we can do with the tool, and hopefully give you a little bit of hands-on so you can play with it yourself. It's very early days for the tool, so I managed to give it a problem that it actually gives the right answer to it, but it's not as useful as the real another answer would be. So somehow I've tricked it. So Richard is looking at that. Not now, I hope, right? Where are you? No? Okay. What are you doing? Waiting for a file to copy. Okay, so do you think we can go through a small demo while we're waiting for the file to copy, or is the that's a problem. That's like 5 minutes to copy. What kind of sticks do you buy, anyways? So the USB 1? Oh my gosh. Where's your supervisor? Pay him more. Right. So, okay. Yes, okay. Yeah, I got it. So I guess I can maybe tell you a bit more of how it's working and why I don't want to do a demo while it's copying off to the USB stick, is because we are actually looking at the problem well, both top down and bottom up at the same time, which means that we are looking at the hardware counters. Okay, and the fact that we're doing a copy of the file from the machine to the stick, you know what? Let's demo it anyways. You ready? We're just going to get an incorrect answer because it's going to pick up all the file transfer.
It's not running the virtual machine to do that stuff.
You want me to run a virtual machine? Okay, so let's start up a virtual machine here, and then we'll, this part, the boring part is over here, because, we're just running virtual machine and web app and stuff like that. The exciting part is over there, but I have to say that even the exciting part is very boring, because we don't have like flashy drill downs and things like that you have to muck through. And so it really does make for a boring demo. That's why it's nicer to get your hands on to see what we can actually do. Okay, now VirtualBox is running. What did you do to it? Oh, right, okay, let me power it up here. Can we see over there? Okay, let me just deal with that too. What the heck did you do? Oh, that looks wild. Okay, so he's mucked with my VM. Ah, okay. I have another issue too because we're coming up. I think I'm in Grub, Debian Grub right now.
Oh, yeah.
Okay, I will do that then. Oops. Hold on. Let's power off the machine and reboot. Yeah, it's very exciting, right? And we're still coming up in Grub. Capture and come on, boot. Are you on the Wi-Fi yet? Okay. Feel free to interject comments and questions as we go along. Now would be a good time. Okay, where'd my mouse go to? What do you do with my mouse? Is it spinning around over there someplace? No, it's got to be over here. Yeah? Yeah. Yeah, sure. Do I know more about the merge between JRocket and Hotspot? Is there anything specifically you're interested in? Because that's a very broad question. It's already happened. It's already happened. No, that's not part of it. That's not part of it. Yeah, well, I mean, I can talk about that. That's like really disappointing. We got rid of PermGen in a space where we had tools to deal with the problems, and now we have Metaspace, right? Which looks like PermSpace, although unfortunately it's built out in a place where we don't have any tooling to deal with the problems. The problems haven't gone away, right? They've just been moved, and now we don't have any tooling to deal with it. Next. Okay. I mean, quite honestly, I mean, that's one of the things we were mentioning when they actually decided to get rid of PermSpace. It's saying like, great, okay, you're not fixing, I mean, the real fundamental problem here is class loading, yeah, and the fact that, well, as I've been talking to one of the JEE spec leads today, that the JEE specification doesn't have a class loading portion of it, which is really bad because that means there's no standard way that JEE applications load classes, which should mean that they should default to the JSE class loading model, which is well defined, but unfortunately there's not a single application server development team, or at least not one that I know of, that's actually read the JSE class loading specification. And I can tell you because I've looked at some of the source code for some of the class loading stuff that goes on for tools, well, for various tools that are supposed to work in these environments. Consequently, we have application servers all doing it one way or another, and then we have OSGI coming in and really buggering it up. Okay, so you know, whether you like OSGI or not, you have to admit that they've completely broken class loading. So consequently, so everybody does it differently, yeah, and it's a problem. So one of the things that we're hoping is that the JEE guys will actually get down and write a specification that's like, this is how class loading is supposed to work in an application server. And we understand, I mean, if you look at, oh, that's cute. It's actually up now. Is it registered? Oh, probably, oh no, we don't have the right address there. Okay, yeah, go ahead. Yeah, okay. Right. Okay. So if you look at the normal class loading model, the normal class loading model is delegating, right? So what we're going to do is we're going to ask the parent if you have the class, right? But we don't want to do that with a JEE application server because when we pack up an year or a war, what we need to do is we need to have the classes that are in the war or the year file or RAR or whatever override what might have been previously loaded. Okay, and you know, and that's as soon as you've done that, you've broken things, right? Yeah. Anyways, that problem hasn't been fixed. right? And the problems associated with that cause the class loader leaks, because you get all these like references between things in different class loaders. That hasn't gone away. So now we're going to leak all of the stuff into general heap. We're going to leak it into metaspace, right? And metaspace is going to be in C space. So instead of seeing an out of memory error perm space exhausted, we're going to see our virtual machine get bigger and bigger and bigger, right? And the performance is just going to drop gradually over time as the VM gets bigger and bigger and bigger, right? And again, we don't really have tools to diagnose what's going on in that area. I mean, we asked for it to be toolable, but unfortunately, I don't think they had enough resources to make it toolable just yet. So, have fun, guys. That's all I can say. So that wasn't. I mean, the decision for doing that was I'm not sure. I talked to some of the guys about it, and it was. It didn't seem like they had real good justification, in my humble opinion, for making that. But that's my humble opinion. Yeah.
Is there a web browser that works on your laptop?
Absolutely. Safari. Yeah. Okay. Should I trust you with my laptop now? Probably not. Yeah. Okay. Okay, so in terms of the other things that are merging, basically, okay, so if you look at the difference between JRocket and OpenJDK, right? JRocket was no interpreter, and they had slightly different memory structures and heap organizations and things like that. Pretty much all that stuff is gone, right? We're not going to see that. What we are going to see, or what we are seeing, is flight recorder and mission control injected into OpenJDK. Well, Oracle's version of OpenJDK. Yeah, exactly. Well, we've been having some. If you're laughing, right? You should be. Yeah. So I'm not. Okay, we're trying to figure out what they've done there. And quite frankly, I haven't quite been able to figure out what they've done yet, mostly because, well, it's been a timing issue. We're just sorting things out now. So it looks like they've injected some code into OpenJDK, and it looks like they inject some code on the build, right? Their own proprietary build. And it looks like it's commercial, where you have to pay money to use it under some circumstances. And other circumstances, you can just use it for fun, for free, right? So right now, the current API, I've been told I should be getting a description of what it might look like, but it's unsupported. By the time we get to JDK 9, apparently that will be a supported API. And it might be possible, although I have no idea how this is going to work, that we could write our own tooling against the flight recorder that's bits that have been injected into OpenJDK, right? So it's a real kind of screwed up mix of commercial on top of open source, and really we need a few people to complain about that, because I started complaining about it, but saying this seems like an inappropriate mix. I mean, if they fork and take it internal to Oracle, I don't really care. When they start injecting code support for this back into OpenJDK and then say you're not allowed to use it. Yeah, okay. I mean, that's my opinion, and mine alone.
Okay.
Are we...
Should we try a demo?
Yeah, that's what we're here for, right? Instead of listening to me spout off about things I don't know anything about. Okay.
Okay. So the first thing I want to do is everyone in the room to cross your fingers, because given the luck we've got today, everyone...
Yeah. Yeah.
So, just for context, the original plan...
I was going to just give him mine, but since I don't have anything else to say. Yeah, the original plan is I had an application, but...
See, the original plan was Kirk had an application. We were going to give you all a VirtualBox instance. You were going to tune the VirtualBox instance, and everything was going to be happy. But due to a combination of diagnosis issues, as Kirk points out, kind of alpha beta level software, and issues with VirtualBox, etc., that's not working out.
Yeah.
So,
can I just say, interject something here? Sorry. Is that what we've been finding is that the virtualized world is a really interesting world to work in. It works very differently than a real hardware world, and it does play havoc with some of the things that you would expect to work in a certain way that just simply don't. Anyways, sorry, Richard, continue.
So I'm moving to the backup plan, which is that I've spun up a bunch of EC2 nodes and connected them to one of our remotely hosted dashboards, and then we'll just go through this.
And we all know that EC2 it works brilliantly also.
EC2 is fantastic, bundle of fun. Anyone here use EC2? Anyone have the issue when you say spawn up an EC2 node and it just does nothing and fails after a while and doesn't tell you? Yeah, happens once in a while. Anyway, right. So that's like the main so basically if you logged into our product and you had a bunch of servers connected, you'd see something that looks a bit like this.
Yeah.
So the top kind of bunch of nodes are...
Can I unpack you a little bit?
Yeah.
Maybe we can just draw a little bit of what the architecture looks like on the paper there.
Okay.
So they know what you're actually logging into. Yeah.
Sorry, was that a question?
I had a slide to show it, but he was actually using my laptop, so I didn't bring it up. It's okay.
So just to clarify, we've got a couple of EC2 nodes over here. So these would be, in terms of a deployment model, your servers running your software. In this case, I've just got a bunch of simulators sitting there, crunching away, eating money, as EC2 does. And they're connected back to a reporting agent that we're hosting. So this is like the default combination. If you want that reporting agent hosted inside your premises, that's also possible, but you'll need to talk to us about that. And then I've just taken Kirk's laptop and connected it up to the web interface of this reporting agent. Now, there's just a connection here that's monitoring these guys, and the display of who's online and who's offline is what's on the screen over there.
Yeah.
Is that clarifying?
Yeah, sure. So basically on the EC2 instances, we have an agent that's just going to monitor the VM. So anything that's launched on that VM, right, this agent is going to look after it. The VM, the actual, yes, I know.
Yeah.
Yeah, when I mean VM, when I say Java VM, I'll be explicit and say JVM, as opposed to when I say VM, then we'll talk about, well, EC2 node, is that better? Okay, thank you. We'll adjust our vocabulary here. Okay,
so you can probably see a few kind of older nodes which are sat there, which have been connected earlier today. We keep those kind of guys around for a while, or you can look at historically who's connected, that kind of stuff. I think this was actually a demo that Martin gave earlier today, so that's interesting. These new guys with the little green ticks, by the way, that's just showing that those EC2 nodes are online and they're connected up. And we've also made in this demo the host name of each EC2 node is hopefully the name of the kind of different type of problem that's happening on the application that's running on that node. So if we click diagnose, or
you looking for a replacement? Hopefully it's okay. Did that close when it
yeah, I think we're okay. Let's roll with it.
Okay. It's only a laptop. Yeah, exactly.
So each of these guys are were coming back individually once they diagnosed it. As you can see, that's pretty fast, given that's the whole diagnosis process. And
so before we go here, like,
yeah.
Mick, can I ask you a question? It's like, that's like got a grindy thing over here, like
yep.
gears. That's got a cup, and that's got a garbage can, and...
So each of these icons kind of correspond to like a different kind of category of problems. So the cup is like, you know, your computer sitting around there wanting to have a cup of tea. It's not really making good use of its CPU. CPU isn't pushing itself, it's just kind of idle. Where are we? The kind of cogsy thing is that your problem is really down to kind of an operating system or a hardware level issue. So it's not something that's necessarily, I mean, it might be something in your application code, but it could be something like you're kind of driving your disk too much, or you're trying to drive your operating system's thread scheduler too much, you're putting too much pressure down at that level. And where are we? Okay.
I thought there was a third one up there, but it seems to have disappeared. Yeah.
If we look at this guy here, which is kind of garbage can, that's a GC related issue. So that's where your application is running application code, but its progress is primarily being bottlenecked on GC. So if we have a look at these kind of more detailed breakdown reports for each of the different programs, so so this is like a kind of GC breakdown, where I don't know if anyone's used our GC log analyzer, Sensum, but we're also planning on somewhere down the product roadmap integrating the technology from Sensum so we get much, much better and more detailed GC breakdowns. So this is a simulator which is got a whole load of object creation and a whole load of objects that are sitting there filling up tenured and causing a lot of your GCs to happen over tenured.
So in this case, were we doing like a full GC, or were just a lot of CMS cycles?
This guy ends up, I think what happens is he starts doing loads of CMS cycles and then ends up doing loads of full GCs as well.
Right. Okay. So we go into we do concurrent mode failures then.
Yeah. So this guy here is an application which is insufficiently parallel. So that means you've got, say you've got like, I don't know, a 4-core box, and you're using one core, you're using it loads, but you're not using all of those cores. So as you can see for each problem, there's also an action plan which recommends what you need to do to address the problem. So here it might be, say it's a servlet container type application, you might just need to increase the size of your thread pool. If it's something more complex or in-depth, you might need to do a lot more kind of re-architecting to extract that parallelism out. In the case of this simulator, it's just the simulator that's doing something on a single thread, but not really using the rest of the CPU cores.
Yeah. So one of the things that we plan to do as we mature the product is actually to be able to tunnel deeper into these problems, so that we're not going to give you like this fairly generic description of what's going on, but we can go into each of the application servers and we can understand what's going on inside the application server and use those particular patterns to say, yeah, I mean, your thread pool is exhausted, or your thread pool is insufficiently sized, or something like that. And we plan on just putting deeper metrics on each of these branches, right?
So this is actually a good example of that kind of progress, because this is the currently deployed live one, but I was actually on the train over the way over here to France today, improving the analytics for this. So hopefully that should be deployed next week, I'll hope. So hopefully as of next week onwards, you'll get a proper thread breakdown, which will show you which threads are the ones which are actually doing use the time, and in addition to that, an execution profile to see where in your code you're actually executing that tells you that you've got this insufficient parallelism problem.
Are you brave enough to show that?
I'm more than brave enough to show the UI, assuming my laptop's still working, but my laptop didn't connect to the connect to the monitor, so I can't.
Yeah,
so there's an issue here. So this simulator is a simulator that spends a heck of a lot of time writing to disk, so it's kind of very I/O bottlenecked, and you get a breakdown showing what process is hitting your disk and how much of your disk capacity you're actually using. If there are multiple applications there which were all contending for this on the disk I/O, you'd see a breakdown between several of them.
Yeah, and that's a good point, right? In this case, what we're doing is we're doing a machine-level view of what's happening, right? So that's what's happening in aggregate across everything that happens to be using the machine. And so what we want to do afterwards is to move up and say, okay, it's aggregate because all your JVMs are writing, in this case, I don't know, we got 4 and they're all writing 12. And 4 JVMs and they're all writing 12 megabytes per second. Or it might be just one JVM that's offensive, right? So we'll go into that JVM, see who the offending thread is that's causing all of this excess writing, or what part of the application is causing excess writing. so that we can actually give that as a report to people, right, as opposed to having to drill down to find this stuff. So we know where the problems are. We know how to get there. So why are we forcing you to do the work to get to it in that case?
This view is also another view which I think as of next week we'll have a proper execution profile breakdown for the code to show you where to go back for that kind of stuff.
Right.
And you've got a context switching problem. So do people know what I mean by context switching?
Yeah.
So you've got multiple processes. They're all contending for the CPU. So in this case, it's actually a program which has got a heck of a lot of lock contention. So you've got a bunch of threads which are all waiting on one hot lock, and the operating system thread scheduler is all trying to throw them in there, trying to get them to find the right thread to be the next one to progress. And that ends up generating a heck of a lot of context switching. And you'll see on the right-hand side, 19% of the time means 19% of your application, 19% of your CPU usage is purely the OS sitting there, running away, context switching.
Yeah.
And that's an underestimate of how bad the problem is for context switching, because it ignores the negative effects on, CPU cache locality that you get when you're doing a lot of context switching.
Yeah, normally when you get a lot of context switching, the 100% number on the CPU is just absolutely unattainable. Normally we'll see like CPU saturations at about 40 to 50%, and that's as much as you can get out of a CPU that's when it's that much contention in play.
So another of the kind of problem classes that we diagnose down to is threads waiting on an external service. So this is like, I don't know, say you're running your application, it's making a call to some RESTful API somewhere else, maybe inside your company, maybe externally, and whoever manages that service is having a really, really bad day. Things are really, really slow, and your application is spending all its time just sitting there, waiting, trying to talk to that box. So this is similar to which is just trying to connect somewhere off box and kind of really gets stuck there on the kind of server socket connections.
Yeah. Again, this is one way you can exhaust thread pools in application servers. So we're going to take a thread out of a pool, make a synchronous call to something, and we're just basically you're going to lock it up. And then your thread pool gets exhausted, and then your incoming requests don't get proper services. And this is a way of calming down the system, right? The system looks really calm because it looks like there's no activity on it in these cases, right? So that's really some of the patterns that we're actually looking for.
Okay. And the other issue that we've got listed here is a deadlock, which is just, straight old. Two threads, one holds the resource the other guy is looking for, the other thread is holding the resource that that guy's looking for, and it gets bottlenecked on a deadlock. So that can obviously, again, kind of restrict the progress of your application performance-wise, because it's not able to do anything because it's deadlocked. There is another case which we don't actually even bother demoing for, because it's kind of really, really obvious, which is just that your application is reasonably well-tuned, it's just spending all its time doing CPU, just doing the application, and in that case we just give you a plain old execution profile, because that's a situation where you just need to kind of perhaps rewrite your code a little bit just to make it more efficient. Okay, I think that covers things.
Yeah, pretty much. That's the very fast high-level view
Yes.
of what's going on. So if you look at all the problems that are being dealt with here, and there's more that we can actually deal with. You can see what we're actually doing is we're just using some patterns as to how the hardware is being used to infer what's going on in the application layer. And then we're going to take some knowledge about what's happening in the applications, how they're built, how they're constructed, to actually do further diagnosis so that we can actually come up with some really useful answers that you don't have to drill down for. And so we have this running in a couple of production environments now. And so far, the feedback from them has been helpful to help to get them to find problems that.
The first customer we deployed to actually had a problem which was actually was actually kind of a misconfigured firewall stopping certain types of connections getting through to their application. And I think they spent, not necessarily people full-time always looking at it, but they were kind of wondering why the problem was going on. And I think they spent a couple of weeks just kind of looking through, trying one thing or other. But it didn't at all stop to think, hang on, it might be a firewall configuration issue. And I think about, within the first minute of getting JClarity up and running on their servers, they'd run a diagnosis and already pointed out that your application is just sitting there not doing very much. And then it clicked that the problem happened about the same time as they made a bunch of configuration changes, and it was actually a firewall thing. So I think we had a useful time-saving customer interaction on the first guy we deployed to within 5 minutes of them being deployed.
Yeah, so not too many customer success stories yet, but I think we're starting to build that story out as we put the tool up into more interesting situations.
Yeah.
I guess.
Questions?
Do you want to try it on the other application, or are you afraid to see how it might fail or work?
I don't think it's going to work that effectively. I think I need to take that back and fix that.
And see what's going on. Yeah. Okay. So we'll. I managed to give it a demo that fooled it. Sorry. I apologize for that. Is there any questions you have about what it is we're trying to do, or comments or feedback? Yeah, sure. Please fire away.
The first one is, can a system be classified in several categories at the same time? Or are you assigning a single category?
We try and find the
not the most probability. It's not probability. This is going. So we're not dealing with probabilities here. We're going to find the most significant performance issue in the system, and there's a reason for going after the most significant one. First is because that often masks or somehow will cause other things to manifest themselves in the performance profile. And once you deal with the most significant one, you can find that the performance profile of your application is going to change radically or significantly in a number of cases. And some things that might have been a problem or looked like they were a problem when you had this particular problem in play. You take away that problem, these things go away with it, and some other problems might show up, right? So, because of that, we want to focus on, what is it that your system is doing? Statistically, what is your system doing most of the time, right? Is it abusing the hardware, right? Do we have some algorithmic issues? Are we capable of saturating hardware? And there's a whole class of things that lists of questions that we can ask, and then somehow map that back into the application so that we can say, okay, this is what's going on. Here's the answer we're going to give you.
Yeah, I think the only thing I'd add to that is there's only one scenario where we might give you more than one answer, which is when you've got multiple applications running on the same server, but they're doing different things and they're not competing with each other for resources. So we know that there's no interference between the two things that could cause a problem, right, and they might be doing slightly different things. So you might get, say, a different execution profile from the two different applications. So that's the only way it might settle down. But yeah,
I think one of the things that how we look at hardware might be different than how you guys look at hardware, or processes and threads and things like that. From a hardware point of view, there's no such thing as a process. There are no such things as threads. There's just streams of instructions and data that are flowing at me, and streams of data that I'm pushing back out the other end, right? So so if you look at the problem that way, right, and you realize that what you're going to get is an aggregate picture of what's going on. When you look at a particular piece of hardware, that's what makes dealing with virtual machines so difficult, right? Because the virtual machine is trying to give you that view, but quite often, well, we've seen with VirtualBox, for instance, like you try MP-stat, doesn't work.
Yeah. Right.
We don't get disk I/O rates, or I/O, or any data rates on the channel.
Same with if you run IO top on an OpenVZ
right.
instance, or Virtuoso, or the products in that space.
Right.
Zen, which EC2 use, is actually one of the better ones for being honest about what's happening under the hood. But there's all these kind of different things which you need to which we're kind of building up and working around case by case.
Right, and some of it means that we're just going to go down to the bare metal, and we're going to see what's going on down there in the bare metal, and then we're going to correlate that to what's going up in the application. So again, it comes from my view of performance tuning, which is really that it's a problem of resource allocation in most cases. So what we want to do is we want to understand what the resource allocation picture looks like, and then try to understand why the resource allocation picture looks that way. Right, and most of the performance problems are going to come from some sort of resource allocation problem. And if you look at the problem that way, then I think it's quite different than let's capture every metric we possibly can from the system, and then use all of this data to try to sort out what's gone wrong after something has gone wrong. Yeah.
You said you had another question?
Yeah. Second question. Are you able to detect any issue with the memory or paging system of a computer? Because
You mean like
pretty hard to debug.
Like swapping.
It's swap
Swappiness.
issue.
Yeah, swappiness. Yeah.
So we do have some stats. So we, at the moment, if you've got a swap issue and you diagnose, we'll tell you you've got a disk I/O problem, because that's what you have. But swap-specific analytics, I think, should be coming relatively soon. The issue with diagnosing swap problems, though, is sometimes when there's a swap issue, our monitor on the box is also impeded by that swap issue.
Yeah.
So I think the long-term solution is to detect swap issues before they happen and try and give you that feedback. Well, we can't do that today, but that's the goal to deal with this swap problem.
Yeah.
Because not only the swap, but also generate the paging. Sometimes you have some very weird behavior on paging,
Right.
especially on the processor systems, where you have reclaim zones that just sometimes 3 pages are actually active, and you just lose performance because then you need to reclaim the
Yeah.
page.
I don't think we're that deep into the operating systems yet, but that's definitely a direction that we want to go. We want to monitor everything that's going to impede, the forward progress of your application. And definitely these type of weird problems, especially in multiprocessor, you get like pages being evicted when they shouldn't be evicted. But they all show up in some of the counter values that we know that are available to us. From our point of view, it's just a matter of maturity before we get there. But definitely swapping is. I didn't see exactly when it was coming, but. Yes, right. Yeah, because I mean, there's all kinds of other things that we're looking at. Like we're looking like other hardware counters, like things that people just don't diagnose, right? Like T-labs. Right. People don't look at your translation look-aside buffers, right? And they don't really understand. Even if I was to tell you what your T-lab hits, miss, walk times were, right? You probably wouldn't know how to react to that or understand what impact that had on the performance of your application. And if we get into certain metrics, I mean, there's certain things that we know we can do to improve the picture.
So doing things like recommending that you enable
large pages, yeah.
Is something which we have some analytics on. They're not quite there yet, but they should be coming hopefully sometime soon.
Right, but we know what the conditions are to make that recommendation. It's just a matter of getting the heuristics into the engine at this point. Any other questions? These are good questions. Yeah.
So, for example, on VirtualBox, anything that's I/O weight actually appears as system time in the kernel, because the VirtualBox driver sits at the wrong place in the kernel, and the time gets counted as part of the wrong thing. So it's not that the information isn't there, it's just that we need to refine our algorithm a little bit more to say, hey, we're in this other situation, we need to, you know, turn the knobs a little bit and focus on this information rather than that information.
Yeah.
And I've looked at a few of the virtualized environments, and they lie to you, but as I say, the information's always there, you've just got to look in a different place.
And tease it out.
Yeah, but
Yeah.
for example, I've run some customers where they had oversubscribed memory.
Yeah.
Sometimes the memory would just swap to disk, actually, on the
Yeah.
environment, but the application would still think they have memory.
Right.
So the memory write rate or read rate would just collapse.
Right, and that's what we'll detect. The memory read rate, write rates will collapse. The instruction retirement rates will collapse. So you're going to just get a collapse of output through the hardware as it tries to deal with this this problem, right? And those are the things that we will pick up on. They'll feed into our heuristic engines, and we'll just say that's when these things are happening, it's an indication that yeah you're swapping, and yeah the virtual machines in those cases will lie to you, but the real hardware won't. So we'll just rely on the things that we know are going to be true, and if we if we know that they're not going to be true, then we're going to somehow tease that information out of what's available. Like we can tease idle out of system. Like right now, if I'm running VirtualBox here, you can just see it drives the system times on the machine like really, really freaking high, and that's not all. It's not really all system time. There's something else going on there that's driving it, so we can tease that out.
Are there any other questions?
Trying to look at some personal plugins. What I want to add my own heuristic.
You want to add your own heuristic?
We haven't really made any plans for adding your own heuristics into the engine.
Can I throw a follow-up question back to you? Like, what kind of heuristics would you like to be able to add?
Yeah.
One that's missing a little part, something like that. I don't have the complete list. I announced it.
Yeah.
Of course.
Okay. I'm not sure we've completely figured out what we'd like to do on this front. There's been some discussion, I think, about
Yeah.
kind of plugins, community, that kind of having more of an ecosystem. I don't think we've really thought it through. I think one thing we've thought about a lot more is trying to get people to add in kind of business domain related information. So stuff about your application that you know that we can't do a general, it applies to all applications.
Right.
To be able to feed those numbers into the system.
Yeah.
And then say, have some way of using that to either improve our historical analysis, or do predictive analysis, or do
I have an example.
Yeah.
Okay, so we get a good friend of ours, right? He's written a system where he calls system GC once a day on the system, right? And it's an exceptionally well-tuned system. It's just fantastically tuned, and what he's doing is absolutely correct, right? But our heuristics would probably pick that up as that, because his full GC to GC ratio is really, really high because of this. And so, our heuristics would probably pick that up and say, like, wow, somebody's calling system GC, and it's really it looks like a speculative call. It looks regular, based on some frequency analysis, and we'd probably want to complain about it, right? But in this case, he could tell our system saying, like, hey, I'm going to do this, ignore it, right? I'm not really interested in this because I built the system to behave this way, and that's something like that would give us more information so that we could say, okay, that looks like a problem that we don't really need to worry about, or it's not a problem because the customer is saying it's not a problem.
Yeah, I was going to say another thing we thought about a lot more for doing kind of user input into the analytics engine on is people sending more information about what their goals and expectations out of it. Like, is it a low latency trading app? Are you just looking at more generic throughput? That kind of trade-off as well. So that's another way we were looking at getting kind of user input into the system. I know that's not quite a plugin, but
Yeah, the thing is, I think what you might be thinking of is in the traditional type of products like AppDynamics or something where they have a plugin framework, where if you're interested in monitoring a certain aspect of of the system, then you can just put the probe in, or JX Insight does this, right? You can write the probe, and it's going to go after some specific performance metric that you want to measure, and then it's going to feed that back into the pipeline, right? And then all that data is going to be stored in a database, and now you can do queries against it using their eye candy and stuff like that. And this system is architected completely differently than that. We're not doing that type of stuff with this particular system. So the type of plugins that you're thinking about, or that I'm guessing you're thinking about, I don't think it would be appropriate for this type of system. Now, when we get into building the other half of the product, so this is like one half of the product, there's a whole other half that has to be done, then there's potential there for people wanting to put specific plugins in to monitor things. One of the things that we want to do with this tool is we want to make sure that it runs very quietly and it runs very, very lightly. So I don't know, we've done a measure on the network utilization recently.
Unless you're actually diagnosing a problem, it does nothing.
Well, yeah, practically nothing unless you're diagnosing. The initial implementations we had were running in 8 megabyte heaps, right? I don't think we can get it down to that now, but we can still run in very small heaps.
I think we can run in 8 meg heaps, I think.
Yeah, you think? Okay, I was thinking probably 16 nowadays, but this is part of the philosophy behind the tooling too, is that it's your hardware to run your application. It's not our hardware to run our diagnostic tooling on, and our monitoring tooling on, right? So we want to stay off of the hardware as much as possible, and we've built the tool like that right from the beginning, so that it's very, very light. It's very network light. It's very CPU light. It's just very resource light. To get through all the diagnostics. The overhead?
Well, unless you're actually diagnosing a problem, it'll be less than 1% of everything.
And when you're diagnosing a problem, when you're diagnosing something, it's still not much greater than a couple of percentage points.
It'll be a few percent when you're diagnosing stuff.
Right.
But
we're in single digit. And we want to remain in single digit. So that means we're not going to let you put your probe in. Yeah, that's your problem. Yeah. Well, I mean, the other thing is that if you feel that you need to put a probe in, then we're scratching our head wondering what we haven't been able to cover off.
If you've got like more specific examples or kind of concrete things.
Yeah, we'd love to talk to you. Yeah. Yeah, sure.
Yeah.
Well, yeah, because there isn't a complete list. No, and I say that it's not because we don't have a list or it can't be complete. It's just that we're trying to be able to diagnose things that we don't know about. Okay? In order for this to work, we have to be able to diagnose things that we don't know about today. Okay? So, sorry? Well, think about it. You think about how we're doing the tooling here, right? We're doing pattern matching and diagnosing off the pattern. I cannot possibly predict all of the performance problems that are ever going to happen in the planet. But I face them every day, all kinds of ones I've never seen before, and I use a bunch of heuristics to come to some conclusion as to what the problem is, right? And that's the whole point behind the tooling, is that we want to use some of these same heuristics to come to some conclusion as to what the problem is. Okay? But since I can't predict what the problems are going to be, I can't give you a list of what we can diagnose and what we can't diagnose. But I can say that if you are in a situation where you're oversubscribed to some particular resource, okay, whatever that resource is, we're going to find it, and we're going to tell you about it, either on an aggregate situation or in an individual situation.
You talked about some the mistakes that are not complete yet.
Yes, absolutely.
So that's the kind of thing that
That's a maturity.
this or this, I might like to just add one of the elements to check that it's not just one line.
Sure. Yeah, I don't think. I'm not saying we'd never allow plugins, but I don't think that's going to happen in the short term, at least.
Right.
So but yeah, I think it's more a question of. One of the things is once you have a plugin API or a service or anything that interacts with other users, you have to like maintain that for life. So we're really careful about not wanting to get this kind of thing wrong, which is why I say we've discussed a few of the kind of domain-specific interaction things, but not the analytics-specific interaction. But it's an interesting point. I think we should probably take that.
Well, I think there's going to be a point in time where we're going to have to allow it on, especially when we go to the second half of the product build.
Yeah.
So there's definitely going to be something that's going to be there, because we're not going to be able to capture everything in the other half of the build. But in terms of what we're doing here, I think we should be able to capture.
Nice stuff.
We should be able to capture most stuff.
Because we're talking about heuristics, so it's normally since it's a SaaS application, it's possible that you can grab the data of all the systems that are your clients and use them to detect false positives, and you can reuse all these data
Yeah.
to improve your heuristic. So it's learning and
Yeah.
the way it works.
Yes.
Yeah. So we expect to get better over time, just through that alone. Plus actual work.
Well, yeah, plus actual work. Yeah, there's some learning stuff in there, so that over time it should get better after the learning gets refined. So, yeah. So, like I said, it's really a completely different model than probably what you're used to looking at. Yeah. I'm sorry? Yeah, like say I'm putting myself out of a job, right? Yes. That's good. Yeah, that's. I mean, I think that's the point, right? It's like there's a whole host of problems that I go in to solve now that are, shall we say, it's boring. So why not get a machine to do that? The machine's a lot faster than I am, and probably a lot cheaper. Yeah, exactly. And I think the other thing too is, like, if you don't have a real skilled performance person on site, right? Maybe you're not big enough to manage that. I mean, I deal with a lot of companies that just say, I need spot performance consulting. I don't need a full-time person. Yeah. And so if we can get a smarter heuristic engine in to help them, then that sort of gives them that capability that they that they don't have currently. And if you look at the existing tooling, you still have to be a fairly clever performance person in order to understand what the tooling is telling you. You still have to be able to dig around, root around, and try to sort out what's going on. But yeah, well, so we're trying to collect enough data so that by the time it gets into a bug report or something like that, that the people who are actually reading it are going like, yeah, okay, no problem. I'm just going to go there and make some adjustments there. Yeah, and that's really the end game.
Mm-hmm.
In this case. So, like I said, this is really going to be like 4th gen. So anything you've seen in 1st, 2nd, and 3rd gen is really not where we want to be. We don't want to do that stuff.
Are there any other questions?
Or at least we'll do it, but not expose it to you. Yeah? Sorry,
I'm pretty skeptical at this point whether that virtual box stuff is going to work out, to be honest. Because it after several especially after dropping my laptop, after several tries, it just wasn't connecting to the Wi-Fi properly.
wasn't connected. Okay, and if we can't get that to connect to the Wi-Fi
It doesn't
properly.
even matter whether there's
Yeah,
Wi-Fi
one of the issues we have with it is that we were trying to run the reporting agent and the diagnostic agent and the test harness and everything on the same virtual machine, and of course, since the agent is sensitive to everything that's running on the machine, then it starts picking up that all of this stuff is going on, and it doesn't actually give a proper diagnosis, because you actually need a proper test environment in that case. And it looks like we'll apologize and say that unfortunately doesn't look like we can give people a hands-on tonight. But we do plan on being able to give people a hands-on. I think you can go to our website and sign up and download some stuff, and then and try it on your site yourself. I don't know how that works. I've never done that. Have you?
Well, I've used the product. I've yeah, you just go to the website.
Just go to the website, and there's a form you can fill out, and give it a try that way, I guess. Okay. Okay. Yeah. Thank you guys for coming.